A third subtraction strategy we use in my class is counting back from A, B times, which means in this example the idea would be to count back, starting at 90, count back 64 times. Now that seems like a long way to count back 64 times. This one makes sense if maybe the problem is 90 minus 7. It seems easier to count back 7 times. All right, so it exists as an easier solution. But presented this way, it would be illustrated on a number grid, 90, and the long way for me to do this would be counting 64 times. But we are aware that we can go back 60, 10, 20, 30, 40, 50, 60, and then 1, 2, 3, 4 for an answer of 26. So with some practice on a number grid, some kids are going to need to, at first, we're going to have to really illustrate that difference on a number grid. All right, the fact that I counted back 9 in this row, there's 10, 10, 10, 10, and another 10 of 50, and I counted back 1, 2, 3, 4, 5 here. All right, and that's going to give me the problem 50 plus 5 plus 9, which is 64. And that might seem complicated, but it just illustrates the shortcut that we can go 10, 20, 30, 40, 50, 60, 1, 2, 3, 4. All right, and that becomes a mental strategy. We can also show with the pencil strategy of longs and cubes. There's 64. I'm starting at 90, 80, 70, 60, 50, 40, 30, 29, 28, 27, 26. So now counting back with the base 10 blocks that I'm not getting out, I'm just going to use pencil to show that. And of course we can also do a number line. It just seems, with 64, using this example, it seems a long way back from 64. A long way back from 90, 64 times. So that's why this strategy, since we don't know the answer at the end of the number line, I don't really promote the strategy when we're talking about counting back from A, B times. That one's strictly using pencil, drawing 10s and 1s, 90, 80, 70, 60, 50, 40, 30, 29, 28, 27, 26. No number line with this one because we don't know what's at the end of the number line.